Happy Monday. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. All right, so today we're going to look at another part of section 8.2. But before we do, are there any questions that you have before we go on? All righty. Let's see here. We started to talk about domain and range on Friday, and I want to expand on the idea of domain a little bit more. And let's see. I want to start out with this situation. Let's say we have the function f of x equals 1 divided by the quantity x minus 4. And the question says, or it says to find the domain. Find the domain. So basically, we're looking for all the inputs or the x values that when we put them into the function, they get a range or an output value that is real. Okay, now let's look at f of 4. If we put 4 in for x, we get this. Recall that dividing by 0 is undefined. This is not real. So that means that 4 is not in the domain of f. Now, I just kind of did that by looking at it. Another way you could do it is you could say, well, I don't want the denominator to be 0. So I don't want that to happen. In other words, x minus 4 can't equal 0. Well, if I add 4 to both sides, I get x can't be 4. So there's my domain. My domain is x can't be 4, or it's all real numbers except 4. Now, we're going to use interval notation to write that. And to write that using interval notation, it looks like this. Everything from negative infinity up to but not including 4, in union with everything after 4 going up to positive infinity. Now, in this case, it would be much more, I don't know, it'd be easier to write it this way, but I want you to get used to interval notation, okay? So that's how you would say all real numbers except 4. Do you have any questions about any of that? If you need a review of interval notation, it's back in section 2.7 of the textbook, okay? All right, let's take a look at another example. Let's say I've got h of x equals 3x plus 6. Again, find the domain. Well, any value of x that we put in there, any real number, times 3 plus 6 is going to give us a real number. Nothing there is going to make it divided by 0. So the domain is going to be all real numbers. So we go from negative infinity to positive infinity. Recall, we don't put brackets on negative or positive infinity because they're not included endpoints. It just goes on forever in both directions. Okay, how about this one? S of x equals 9 over 2x plus 1. This one maybe is a little more difficult to see. So what I could do is I could say, okay, let's see, 2x plus 1, when would that equal 0? Well, when 2x is negative 1, when x is negative a half. So basically s of negative a half would be 9 over 0, which is undefined. So I want to say x not equal to negative a half. So the domain, we go from negative infinity up to but not including negative a half, and then after negative a half up to a positive infinity. Okay. Let's see here. We're going to look at graphing some functions. Let's say I've got f of x equals 2x minus 1. So this is a function already in slope intercept form. Y equals mx plus b. Recall that m is the slope, which in this case would be 2 or 2 over 1. And b is the y-intercept, which in this case would be negative 1. So to graph that, we'd start at negative 1 and go up 2 over 1. And let's see here. So there is the graph of f of x equals 2x minus 1. It's the same graph as if we graphed y equals 2x minus 1. It's just that we're graphing it, we're calling it a function because it is a function. Any questions about that one? All right. How about this? Let's see. F of x, let's make this a little bit bigger, equals 2/3 x minus 2. So the slope is 2/3. The y-intercept is negative 2. Starts at negative 2, goes up 2 and over 3, up 2 and over 3. And there is the graph of f of x equals 2/3 x minus 2. Any questions on that one? Okay, let's take a look at one more here. How about this? F of x equals 2. Y equals a constant. Y equals a constant. Y f of x, or what, let's say y equals 2. That's like what? Y equals 0x plus 2. So the slope is 0. So it's a horizontal line going through 2. So there you have f of x equals 2. Any questions about that? All right. I want to review some properties to do with graphing equations of lines. And this is all out of chapter 3. So if you want more review than what I'm going to do here, chapter 3 is where all of this stuff is found. Okay. And there's 10 items I want to look at. First of all, we'll call this item number 1, to find an x-intercept set y equal to 0, or complete the ordered pair something comma 0. All right. Now, graphically, what is an x-intercept? Well, let's see. This graph cuts through the x-axis right there and the y-axis right there. This point right there is the x-intercept. Notice that y is 0. So if you had the equation 2x plus 3y equals 12, and you wanted to find the x-intercept, you'd set y equal to 0. Okay. So for this equation, the x-intercept would be at 6. So that would be over here, kind of thing. All right. Any questions about that? Item number 2, to find a y-intercept, set x equal to 0, or complete that ordered pair. let's go back to the 2x plus 3y equals 12. So to find the y-intercept, we'd set x equal to 0. And y equals 4. So that would be up here. Any questions about that? All right. Number 3, let's look at the slope formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Given two ordered pairs, and this is supposed to be and, let's say I know 2 points that are on a line and I want to find the slope of the line passing through those 2 points. So one of those points is 0.1, one of them is 0.2. 0.1 has an x sub 1 and a y sub 1. 0.2 has an x sub 2 and a y sub 2 as in subscript. All right. So y sub 2 is going to be 6. Y sub 1 is going to be -3. X sub 2 is going to be -5. And x sub 1 is going to be 2. Do the arithmetic. 6 minus -3 would be 6 plus 3, which is 9. -5 minus 2 is -7. So we get -9/7. So the slope is -9/7. Okay with that? All right. Let's see. How about slope intercept form, which I just used a minute ago. Y equals mx plus b. M is the slope of the line, and b is the y-intercept. So y equals 4x minus 7. The slope is 4, or 4 over 1. The y-intercept is -7, which means down here at -7, and then up 4 and over 1, up 4 and over 1, up 4 and over 1, etc., etc. You okay with that? All right. Let's see. Item number 5. Parallel lines have the same slope. So let's say that the slope of line 1 is 2/3 and the slope of line 2 is 2/3. Since the slopes are the same, the lines are parallel. If the lines are parallel, the slopes are the same. Okay? Perpendicular lines have negative reciprocal slopes. Let's see. So here, let's say that line 1 is parallel to line 2. Here we've got line 3 is perpendicular to line 4. Let's say slope 3 is 2/3. Slope 4 would be -3/2. So parallel lines, same slope. Perpendicular lines, the slopes are negative reciprocal. So you flip it over and change the sign of it. Okay. Let's see. Number 7. An equation in the form y equals a number is a horizontal line. So I should say the graph of an equation in the form y equals a number is a horizontal line. Okay. The graph of. So for instance, y equals -7 would look like that. Okay. Number 8, the slope of a horizontal line is 0. So going back here, the slope has no rise or fall over some run. 0 divided by something that's not 0 is going to equal 0. So equation, the graph of an equation of the form y equals a number is a horizontal line and its slope is 0. The graph of an equation in the form x equals a number is a vertical line. So x equals 3. Oops, I missed it there. Would be a vertical line. And 10, the slope of a vertical line is, oops, is undefined, because you're going up or down divided by 0 run. Anything divided by 0 is undefined. Okay, so you've got those 10 ideas that go back to chapter 3 in terms of graphing, and we're going to be using those now. So let's take a look here. It says, write an equation for a linear function whose graph has the given characteristics. All right. It has a slope that is 5 and a y-intercept 0, -3. I could write this information a different way. I could say that m is 5 and b is -3. So using y equals mx plus b, 5 goes there, -3 goes there, y equals 5x minus 3. But it said a linear function, so I'll write f of x equals 5x minus 3. So there's a linear function with a slope of 5 and a y-intercept of -3. Any questions about that problem? Okay, let's take a look at another example. Here we have a slope of 1/5, and it passes through the point 10, 1. So again, using y equals mx plus b, I know the slope is 1/5, so y equals 1/5 x plus b. However, this is not the y-intercept. For it to be the y-intercept, the x-coordinate would have to be 0. But what I can do is I can use this point and take the 10 and put it in for x, and the 1 and put it in for y. And this will allow me to solve for b. So I know the slope and the y-intercept. Y equals 1/5 x minus 1. Writing it using function notation, f of x equals 1/5 x minus 1. Any question there? Here's another example. Write an equation of a linear function that passes through the following points. So it passes through, let's see, 1, 7, and -2, 1. Well, to put it in the form y equals mx plus b, I need the slope and I need the y-intercept. I don't have either one. However, I can use the slope formula along with the 2 points that are given to find the slope. Y sub 2 is 1, y sub 1 is 7, x sub 2 is -2, and x sub 1 is 1. 1 minus 7 is -6, -2 minus 1 is -3. -6 over -3 is 2. So the slope equals 2. So using y equals mx plus b, I get y equals 2x plus b. So I've got the slope. I need to find the y-intercept. Well, I can do the same thing I did on the last problem. Take one of the ordered pairs and plug it in for x and y. I want to be sure to use the same ordered pair for both x and y. Don't choose an x from one point and a y from another. It's got to be the same point. So I'm going to use this point. So x is going to be 1, y is going to be 7. So 7 equals 2 times 1 plus b. 7 equals 2 plus b. Subtract 2 from both sides. B equals 5. So y equals 2x plus 5. Finally, f of x equals 2x plus 5. So there's the equation in function, the function, linear function that passes through the point 1, 7 and -2, 1. I could check my work. If x is 1, 2 times 1 plus 5 is 7, so 1, 7. If x is -2, 2 times -2 plus 5 is 1. Check, check, check. All right. Okay. Here we have a graph that passes through 3, 0. Is that the y-intercept? Anybody? It's not. What is it?
The x-intercept.
It's the x-intercept. Good, because if y is 0, it's the x-intercept. And unfortunately, that's not b. So it's no better than any other ordered pair in terms of what we're doing. It's not like it's the y-intercept. Okay, so it passes through the point 3, 0, and it's parallel to the graph of g of x equals -2/3 x minus 4. Okay, parallel lines have the same slope. Since this slope is -2/3, this slope of the new line is also -2/3. So we now know the slope and one of the points on the line. So using y equals mx plus b, we'll put the slope in. Y equals -2/3 x plus b. Then we'll take the ordered pair that we're given and put 3 in for x and 0 in for y. 0 equals -2/3 times 3 plus b. The 3's reduced down, -2 plus b. Add 2 to both sides, b equals 2. So y equals -2/3 x plus 2. F of x equals -2/3 x plus 2. So this line is parallel to that line. It has the same slope, and it passes through the point 3, 0. So this would be the final answer. Okay. Here we have, let's see. This line passes through the point 1, 2, and it's perpendicular to the graph of g of x equals -x/6 plus 1. Well, -x/6 is like -1/6 x. So the slope of this would be -1/6. What about the slope of the line that's perpendicular? What would that be? If the original slope's -1/6, the perpendicular line slope would be
6.
right, +6/1 or just 6. So now y equals mx plus b. Y equals 6x plus b. Take that point and put 1 in for x and 2 in for y. 2 equals 6 times 1 plus b. 2 equals 6 plus b. subtract 6, -4 equals b. So there's my slope, there's my y-intercept. Y equals 6x minus 4. F of x equals 6x minus 4. So these two lines are perpendicular, and this equation or linear function passes through the point 1, 2 as well. Okay. And another example. All right. We want an equation for a linear function where the graph is horizontal and passes through the point -8, 12. Well, one of the things I reviewed with those 10 ideas is that the equation of a horizontal line is y equals a number. All right. What is the y value of that ordered pair? 12. So y equals 12, or f of x equals 12. Think of it a different way. Let's say we had a horizontal line passing through -8, 12. Okay, so there's point -8, 12. Well, that would be a horizontal line that would be y equals 12. So f of x equals 12. All right. If you took Math 85, back in chapter 3, you did problems just like the ones we went through right now, except that they didn't use function notation. So if this seems familiar, it should be, if, like I said, if you took Math 85. Okay. Now, we're going to take a look at a story problem, and it's going to ask us to read the problem, come up with a function, and then apply the function to a follow-up question. What we're going to do, we've just gone through and looked at how if we have two ordered pairs that a line passes through, we can use those two ordered pairs to get the slope and eventually the y-intercept to get that function. That's what we're going to do. So let me read this story to you, and then we'll go through and look at it. This says nurses. Okay, hang on a second. Here, let me move this over here so I'm looking straight at you there. Okay. The demand for full-time registered nurses in the United States can be modeled by a linear function. Okay. In 2005, and don't panic about all these numbers, I'm going to put them down here again. In 2005, approximately 2,175,500 nurses were needed. By the year 2015, that number is expected to increase to about 2,586,500. Now, this problem is old, obviously, because it's 2020. But anyway, it says let T be the number of years after 2000 and N be the number of full-time registered nurses needed in the US. Write a linear function N of T to model the demand for nurses. Okay, so if our linear function is going to be N of T, that means that T is the input and N is the output. T equals the number of years after the year 2000, and N is number of nurses needed. Okay. Now, let me read it again. The demand for full-time registered nurses in the United States can be modeled by a linear function. In 2005, 2005 would be 5 years after the year 2000. So T would be 5. In 2005, approximately 2,175,500 nurses were needed. 2,175,500. So there's our first ordered pair. The time is 5 years after the year 2000, and the number of nurses, 2,175,500. Everybody okay with how I extracted that ordered pair? Okay. By the year 2015, so now time is 15. the number is expected to increase to about 2,586,500 nurses. I now have two ordered pairs. This is 0.1 and this is 0.2. Now, technically our variables are T and N. I'm going to think of them as X and Y until I get right down to the finish, and then I'll change them over to the appropriate variables. Okay, so the slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1 is going to be 2,586,500 minus 2,175,500 all over 15 minus 5. Well, it's calculator time. Let's see. If I take 2,586,500 minus 2,175,500, I get 411,000. 15 minus 5, I can do that one in my head. Dividing by 10 gets rid of one of the zeros. So the slope is 41100. The slope is 41,100. All right. So y equals mx plus b. That's going to go in the place of m. Y equals 41,100x plus b. I'll use this ordered pair. 5 goes in for x, 2,175,500 goes in for y, and I get 2,175,500 equals 41,100 times 5 plus b. 2,175,500 equals, let's see, 41,100 times 5 is 205,500 plus b. I'm gonna, let's see, I'm gonna recopy that up here. 2,175,500 equals 205,500 plus b. I'm going to subtract 205,500 from both sides. Okay, so 2,175,500 minus 205,500, and I get 197,000 equals b. All right, so using y equals mx plus b, I'd have y equals 41,100 x plus 1,970,000, but I'm actually supposed to be using t and n of t, so it would be n of t equals 41,100 t plus 1,970,000. So there's my final answer. Seemed like a lot of work, but we really did the same thing we did on a problem earlier. Extract two ordered pairs, use the slope formula to find the slope, plug that into y equals mx plus b, take one of the ordered pairs, plug it in for x and y to find b, bada boom, bada bing. Okay, now, the follow-up question says, use your answer in part A, and this was part A, to predict the number of full-time registered nurses that will be needed in 2025 if the trend continues. So the question is this: what T value are we going to use for the year 2025?
25.
Right. So we want to find N of 25. We're going to put 25 in the place of T. N of 25 is going to be 41,100 times 25 plus 1,970,000. So let's see what we get here. 41,100 times 5, oops, times 25, excuse me, plus 1,970,000. And I get 2,997,500. So 2 million, almost 3 million registered nurses. Now, course, back when they wrote this, they didn't know that we were going to have issues like we're having with the virus. So this may or may not be accurate. But anyway, any questions on that? All righty. So I will be back this afternoon. Should you have need of me at 1:15, I'm going to stop the recording